So, let's dive into question 1b from our philosophy document. It talks about the branches of philosophy. Do you want to start with epistemology?
Sure, epistemology is fascinating. It's the study of knowledge, focusing on its nature, scope, and the relationship between truth and belief. Epistemologists ask questions like, what can I know? How is knowledge acquired? Can we be certain of anything?
Right. And within epistemology, there are two major branches, rationalism and empiricism. Rationalists believe that reason is the primary source of knowledge. They argue that we are born with innate ideas that precede any experiences.
Exactly. Empiricists, on the other hand, claim that all knowledge comes from sensory experience. John Locke, a famous empiricist, described the mind as a blank slate at birth, with experience riding on it.
Moving on to the next branch, metaphysics. Metaphysics deals with the fundamental nature of reality and existence. It asks questions like, what is there? What is it like?
Yes, metaphysics covers a lot of ground. It includes ontology, which is the study of being and existence. It also involves cosmology, which looks at the origin and structure of the universe, and theology, which explores the nature of the divine.
Then we have ethics, which is the study of moral principles. Ethics asks questions about what is right and wrong, what we ought to do, and what kind of people we should be.
Ethics is crucial because it guides our actions and decisions. There are different approaches within ethics, like deontology, which focuses on duties and rules, and consequentialism, which considers the outcomes of actions.
Don't forget virtue ethics, which emphasizes the importance of developing good character traits, or virtues, to lead a morally good life.
Right. Another important branch is logic. Logic studies the principles of valid reasoning and argument. It helps us distinguish between good and bad arguments, ensuring that our reasoning processes are sound.
Logic is essential for clear thinking and effective communication. It includes the study of fallacies, which are errors in reasoning, and different types of logical systems, like symbolic logic.
Aesthetics is another branch, focusing on the nature of beauty and art. It explores questions like, what is beauty? How do we evaluate art? What is the role of art in society?
Aesthetics helps us appreciate and critique the arts. It examines our sensory experiences and emotional responses to art, as well as the cultural and social significance of artistic works.
And then there's political philosophy, which studies concepts related to government, justice, rights, and the role of the state. It addresses questions like, what is the best form of government? What rights should individuals have? What is justice?
Political philosophy is vital for understanding and improving our political systems. It involves discussions about democracy, liberty, equality, and the distribution of resources in society.
Finally, there's philosophy of mind, which investigates the nature of the mind and its relationship to the body. It asks questions like, what is consciousness? How do mental states relate to physical states?
The philosophy of mind also explores issues like personal identity, artificial intelligence, and the nature of emotions and thoughts. It's closely related to cognitive science and neuroscience.
Each of these branches offers unique insights and tools for exploring different aspects of human experience and reality. Studying them helps us develop a deeper understanding of the world and our place in it.
Absolutely. Philosophy's breadth and depth are what make it so enriching. Engaging with these different branches enhances our critical thinking and enriches our perspectives on life.
I agree. This conversation has really highlighted the importance and interconnectedness of the various branches of philosophy. It's fascinating how they all contribute to our understanding of the world.
Now let's talk about institutional repositories.
I've been reading about institutional repositories and came across some interesting information. Do you know what institutional repositories are?
Not exactly. Can you explain?
Sure. Institutional repositories (IRs) are a new concept for collecting, managing, disseminating, and preserving scholarly works created in digital form by faculty and students in universities and colleges. They address the issues in the current scholarly communication model, which is dominated by commercial journal publishers and vendors.
That sounds useful. How do libraries implement these repositories?
To properly implement IRS, libraries need to recruit librarians with digital collection management and open archive information system (OA) management skills. Additionally, they need to train faculty and students to use OA, help them prepare their digital products, involve them in institution-wide policy making, and set repository goals.
Interesting. How has the northeastern region of India contributed to this development?
The northeastern region, consisting of 8 states, has 7 central universities, 3 state universities, 2 agricultural universities, and several institutions of national importance. These include Assam University, Tezpur University, Nehru, Nagaland University, Mizoram University, Manipur University, and Rajiv Gandhi University, among others.
What about the impact of information technology on university libraries in this region?
The use of computers and information communication technologies (ICTs) in organizing collections, processing, retrieval, and dissemination of information is becoming common. National agencies like NICNet, InfLibNet, DelNet, and ColibNet have initiated the automation and networking of many universities, leading to the development of bibliographic databases and online services.
That's great progress. What about Assam University specifically?
Assam University, established in 1994, has 31 postgraduate departments and 3 interdisciplinary centers under 9 schools. Its library has a diverse collection of knowledge resources, categorized into 13 collections including textbooks, reference books, periodicals, theses, reports, donated collections, Northeast Collection, and digital resources like CD-ROMs, DVDs, e-journals, and databases.
Wow, that's quite comprehensive. How does the research output from Assam University and other universities in the northeastern region contribute to the overall academic landscape?
The research output includes doctoral and master's theses, research monographs, seminar and conference proceedings, research reports, and publications in peer-reviewed journals. However, these are often only accessible in the respective universities' libraries. Digitizing these resources and making them available online can significantly enhance their accessibility and usage in research and development activities globally.
So, digitizing and creating institutional repositories seems crucial. What steps are being taken to develop these repositories in universities?
Developing institutional repositories involves creating digital content and managing it with the help of open-source software like Space. Universities need to archive research outputs, seminar proceedings, class notes, monographs, annual reports, and other scholarly materials in digital form. These resources can then be accessed over the internet, facilitating wider dissemination and use.
It seems like a lot of work, but definitely worth it. Are there any examples of successful implementations?
Yes, many American and European universities have established institutional repositories. These repositories offer services for managing and disseminating digital materials created by the university community, ensuring long-term preservation and access. They represent a collaborative effort among librarians, IT specialists, archivists, faculty, and administrators.
That's encouraging. How do you think this will evolve in the future?
As universities continue to produce more digital content, the need for institutional repositories will grow. These repositories will become essential for preserving and sharing the intellectual output of academic institutions, supporting research and education on a global scale.
Why do we need to develop institutional repositories in universities?
Developing institutional repositories is crucial because they help bridge the gap between universities with extensive resources and those without. Many universities still rely on traditional print or hybrid formats, which can limit access to scholarly communications. Institutional repositories provide a solution by archiving and disseminating scholarly work, such as research papers, conference proceedings, theses, and other academic outputs, digitally. This ensures that valuable academic resources are accessible not only within the university, but also to a broader audience globally.
What exactly is an institutional repository?
An institutional repository (IR) is essentially a digital archive for collecting, preserving, and disseminating the intellectual output of an institution's academic community. It is based on the principles of open access, where information is freely available to everyone. ERs are managed collaboratively by librarians, information technologists, faculty, and administrators to ensure the long-term preservation and accessibility of digital materials. These repositories not only store research articles and teaching materials, but also experimental data and institutional records, documenting the intellectual life of the institution.
Can you explain the design structure of an information repository?
Sure. The design architecture of an institutional repository typically involves a multi-tier structure divided into three main components. Operational architecture. This includes the systems, services, and data management layers that manage the digital content. Application architecture. It encompasses the applications and services that provide access to the digital content. Technical architecture. This includes the underlying technical infrastructure such as hardware, software, and network components that support the repository.
What kind of hardware and software are needed to set up an institutional repository?
Setting up an IR requires robust hardware and software infrastructure. Key hardware components include high-capacity servers and client computers, desktop workstations, scanners, cameras, and other capture devices, backup storage devices like cartridge tapes or disks, high-speed local area networks, LANs, and internet connectivity through lease lines or VSAT. For software, the essentials are operating system software, optical character recognition (OCR) software, scanning software, digital library software such as Space, Greenstone, Fedora, and Prince, web design software like Java, FrontPage, and XML, database management systems (DBMS) such as Oracle, PostgreSQL, and MySQL, full-text search engines to index and provide access to digital resources.
What are some of the open-source software options available for developing institutional repositories?
Several open-source software options are available for developing ERs, including Space, widely used for managing digital content. EPRINTS, a software for building high-quality OA-compliant repositories. I-TOR, an open-source tool for digital repositories. MyCore, a framework for building repositories. CDSWR, developed by CERN for creating digital libraries. Fedora, a flexible repository platform for the management of digital content. These tools are freely available and can be accessed online for more details.
What international initiatives have been taken regarding institutional repositories?
Internationally, several initiatives have been taken to promote the development of ERs. For instance, the Massachusetts Institute of Technology (MIT) developed the Space system in collaboration with Hewlett-Packard. This system has been adopted by many institutions worldwide and serves as a model for others. Moreover, the Open Archives Initiative Protocol for Metadata Harvesting (OAPMH) has been established to enhance interoperability between digital libraries, facilitating the efficient dissemination of content across different platforms.
What are the future developments anticipated for institutional repositories?
In the future, we can expect to see more universities adopting institutional repositories, either individually or through consortia. There will be a separation of system operation from curatorial and policy control to manage specific sets of content more effectively. Additionally, there might be collaborations with public libraries, local governments, historical societies, and even commercial services to establish community repositories. These developments will enhance the accessibility and preservation of digital content, benefiting a wider audience.
Let's now him on research integrity.
Hey, I've been reading up on research integrity and its importance. It's quite comprehensive. Do you know what research integrity encompasses?
Yes, research integrity is crucial in the scientific community. It essentially means adhering to ethical principles and professional standards that are vital for responsible research practice. It's not just about following rules. It's about adopting these principles as a personal credo.
Absolutely. The definition I read emphasizes active adherence to honesty, trustworthiness, and a high regard for the scientific record. It involves both individual researchers and the institutions they work in. For individuals, it's about moral character and experience. For institutions, it's about creating an environment that promotes responsible conduct.
Right. Individual researchers must commit to intellectual honesty and personal responsibility. This includes various practices like being honest and fair in proposing, performing, and reporting research, accurately representing contributions, being proficient in peer review, and maintaining collegiality in scientific interactions.
They also need to disclose conflicts of interest, protect human subjects, provide humane care for animals, and adhere to the responsibilities of mentors and trainees. It's quite an extensive list. But beyond these practices, research integrity also means examining data objectively and being guided by results rather than preconceived notions.
That's a great point. Institutions play a significant role too. They need to establish and monitor structures, processes, policies, and procedures that promote responsible conduct. Integrity should be seen as an integral part of being a scientist, not just a set of imposed regulations.
Indeed. The document I read also outlined specific areas within research integrity, such as honesty in all research aspects like presenting goals, intentions, findings, reporting methods, gathering data, using and acknowledging others' work, and making justifiable claims based on findings.
Yes, and it also mentions the importance of scrupulous care, thoroughness, and excellence in research practice. This means using appropriate methods, adhering to protocols, drawing valid interpretations, and effectively communicating results.
Transparency and open communication are also key. This includes declaring conflicts of interest, reporting data collection methods, including reuse of data, analyzing and interpreting data transparently, making research findings widely available, and presenting work to both researchers and the public.
Exactly. And there's also the aspect of care and respect for all research participants and subjects, including humans, animals, the environment, and cultural objects. It extends to the stewardship of research and scholarship for future generations.
It's clear that integrity in research is essential for maintaining scientific excellence and public trust. It's more than just a definition. It's a commitment to intellectual honesty and personal responsibility.
Well said. Integrity in research is about the holistic commitment of both individuals and institutions to uphold these ethical principles and standards, ensuring that the research conducted is trustworthy and respected.
Now, about salami slicing in research.
I just read this fact sheet about salami slicing in research. Do you know what that is?
Yeah, I'm familiar with it. Salami slicing is the practice of breaking up a research study that could be one meaningful paper into several smaller papers.
Right, and it's different from duplicate publication. Instead of reporting the exact same data in multiple papers, salami slicing segments a large study into parts. These parts are called slices of the study.
Exactly. It's not considered acceptable if these slices share the same hypotheses, population, and methods. The same slice shouldn't be published more than once.
The U.S. Office of Research Integrity explains that salami slicing can distort the literature. It can mislead readers into thinking that each slice comes from a different subject sample. This skews the scientific database and wastes the time of readers, editors, and reviewers.
Plus, it unfairly boosts the author's citation record, which isn't ethical. However, there are cases where it's legitimate to publish data from large clinical trials or epidemiological studies separately. This is true when the data addresses different and distinct questions with multiple and unrelated endpoints.
When it's legitimate, each paper should clearly define its hypothesis and be presented as one section of a larger study. Most journals require authors to disclose if a manuscript represents fragmented data and to enclose any related papers, whether published or not.
Yes, transparency is key. Authors should send copies of any manuscripts closely related to the one under consideration. This includes manuscripts that are published, recently submitted, or already accepted.
To prevent salami slicing, the guide suggests avoiding the inappropriate segmentation of data into multiple papers. When in doubt, authors should consult with a professor, advisor, or someone in a position of authority.
That's solid advice. And the fact sheet references several sources for more information, including the Journal of Postgraduate Medicine, the Office of Research Integrity, and the Committee on Publication Ethics.
Now, importance of hypothesis in research.
You know, I've been thinking about the role of a hypothesis in research. It's such an integral part of the process. It really provides objectivity and direction to research activities.
Absolutely. Without a hypothesis, researchers would be like sailors without a compass. A good hypothesis allows researchers to investigate new areas of discovery objectively, making it a powerful tool for advancing knowledge.
That's a great analogy. A hypothesis also determines the most appropriate research design and methods for data analysis. It's essential to have one that's economical, relevant to the problem being studied, and aligned with the study's objectives.
Right, and simplicity is crucial. A hypothesis should be formulated in simple and understandable terms. It should also be purposeful, meaning it must be relevant to the research problem and objectives.
I agree. A hypothesis has a profound effect on various research variables. It should have conceptual clarity, consisting of clearly defined and understandable concepts.
And let's not forget empirical referent. No usable hypothesis can embody moral judgments. It needs to be specific and not general, facilitating objectivity and data collection.
Exactly. The availability of techniques is also important. Methods should be available for testing the hypothesis, ensuring it's testable and verifiable, either directly or indirectly observable and measurable.
Yes, and these characteristics like specificity, conceptual clarity, objectivity, empirical referent, simplicity, and testability are essential. The hypothesis must be relevant and economical, with the availability of techniques for testing.
So true. Lundberg defined a hypothesis as a tentative assumption or guess which becomes the basis of action or investigation. Good and Hatt described it as a shrewd guess or inference that explains observed facts or conditions and guides further investigation.
And Bogart said a hypothesis is a proposition to be tested. It's fascinating how these definitions highlight different aspects of what makes a good hypothesis.
It's fascinating how the entire research process is often designed to verify a hypothesis rather than directly finding a solution to a problem or answering a question.
Absolutely. A hypothesis really sets the stage for the research. It's essentially a tentative statement about the solution to a problem. Did you know that the word hypothesis comes from the combination of hypo, meaning tentative, and thesis, meaning statement?
Yes, and it's interesting how it's defined operationally as well. George J. Mooley described it as an assumption whose testability is checked based on its implications with empirical evidence and previous knowledge. It basically predicts the relationship between two or more variables.
Exactly, and a complete hypothesis needs to include three components: the variables, the population, and the relationship between the variables. Without these, it wouldn't be a proper hypothesis.
I also learned about the nature of a hypothesis. For instance, it should be conceptual in nature, stated in a declarative form, and it should indicate a tentative relationship between variables.
Right. It also needs to be empirically testable, meaning it should be verifiable or falsifiable. And it should be a prediction of consequences, not just a moral or ethical statement.
That's a good point. Even if a hypothesis is proven false, it's still considered valuable because it contributes to the advancement of knowledge and can lead to further inquiry. What about the characteristics of a good hypothesis?
A good hypothesis shouldn't be framed as a question, should be specific and precise, and should describe a relationship between variables without conflicting with known laws of nature. It should also be simple, understandable, and testable within a reasonable time.
Yes, and it must explain the facts that necessitated the hypothesis in the first place. It's crucial for guiding the research, providing a framework for investigation, and sometimes even suggesting new theories.
That's why hypotheses are so important. They help in testing theories, guiding research activities, explaining social phenomena, and developing theories. They also determine the most suitable techniques and types of research needed.
In essence, a well-constructed hypothesis not only guides the research process, but also ensures that the investigation is meaningful and grounded in empirical evidence. It's really the backbone of scientific studies.